Hello, today we're going to be solving the first question we are given as a take home in our previous lesson on the law of constant composition or definite proportion. We are given two major questions to get ourselves tested to see how much we got from that very lesson. And here was the very first question we were given. Two samples of lead 2 oxide were prepared first, number one, by heating burning lead metal in oxygen, two, by heating lead trials in nitrate 5. Analysis show 1.22 gram of lead 2 oxide containing 1.13 gram of lead. And also the second result shows 1.56 gram of lead 2 oxide containing 0.11 gram of oxygen. Now, do these whole analysis show that the law of constant composition or definite proportion has been obeyed? Now, let's test if this shows that this very law is being obeyed. Now, the first thing you're going to do, you're going to draw our table. We have our table here. We have the samples. We have the samples of lead 2 oxide as PbO. So the samples, first we have lead right here. And next we have oxygen. So the first sample and then the second sample. Now don't forget, what does this law state? The law states that provided that we have a pure sample or all pure samples of a given chemical compound contains the same atomic number of elements, combined in the same proportion by mass. So don't forget it simply states that regardless of the way a particular compound has been produced, provided is the pure sample of that compound we're talking about, it does not change the composition of that very given compound. So let's see if this law is obeyed. So the first we have is PbO. That's PbO is lithosa. So the first sample we have 1.22 gram of PbO containing 1.13 gram of, I beg your pardon, 1.13 gram of lead. So if you have 1.13 gram of lead here, how much oxygen do we have? So that's going to be 1.22 minus 1.3. That's just simple mathematics. So we have 0.09 gram of oxygen. So the next we have is 1.56 gram of this same PbO contains 0.11 gram of oxygen. 0.11 gram of oxygen. Okay, it does that. And so how much lead are we going to have there? That's 1.56 minus 0.11. I have a 5, 4, 1.45. So you have 1.45 gram of lead. So we're trying to see if the lead oxide produced is truly pure samples of lead 2 oxide. So we're trying to see if the lead oxide produced, are pure samples of lead oxide, it simply means this law is in obey, law of constant composition. So how do we prove this? How do we get to know? Just a simple mathematics to prove that this law is in obey from the two samples gotten. This is what we're going to do. First of all, lead is going to be, let's say lead, how much percent of lead do we have here? I have 1.13 over 1.22 times 100 over 1. So the next oxygen for the first sample is 0.09 over 1.22 times 100 over 1. So let's do the mathematics. I'm going to use a calculator to help us out. I'll speed up things for us. So for right away, we have 1.13 times 100 divided by 1.22. That will give us 92.6. So 92.6%. We have 92.6% of lead in the first sample. So if you have 92.6%, that means it's very you can easily solve this. 100% minus 92.6%. Don't forget law of the same the law of conservation of mass plays a big role here, and that's why what James Louis Prowse did was just to advance Antoine Labiusa's work. So let's see if this is going to work. That's 0.09 times 100. It's going to get the same thing. 100% minus 92.6 to give us 7.4%. Let's solve it using this. That's you see 7.4%. Still the same thing. 7.37%. So that's that for the first sample. So let's see if you're going to get the same thing for this next sample. For this next sample, lead is 1.45 gram of lead over 1.56 gram, which is the absolute mass of the SO2 gas you're talking about. That's BO gas, the bigger part that you're talking about. So how much percent of PB do we have here? I'll be 1.45 times 100 divided by 1.56 So we have a 92.9, that's about 93%. Is approximately 93%. Is approximately 7%. So that's 92.9% approximately 93%. So then the oxygen, 0.11, I beg your pardon, 0.11 over 1.56 times 100 over 1. Very easily, you're gonna get 7%. We're gonna get 7.1% or thereabout. So approximately 7%. So 0.11 times 100 divided by 1.56. That'll give us 7.05%, so 7%. So that's 7%. So as you can see, in the first sample of lead 2 oxide, it shows the first sample shows 93% of lead and 7% of oxygen. Second sample shows 93% of lead and 7% of oxygen. So you can see that there's a constant proportion. That's what we call a law of constant composition. So the composition is constant. The first sample shows lead 93, oxygen 7. Second, lead 93, oxygen 7. So that shows that this very law is obeyed. According to this very law here, this all experimental analysis obeys the law of constant composition. So that's that for that. Please just stay tuned for the solution of the next and take home.